Alright, time for another DraftScience video presentation. I guess I will start by just pointing out that I am offering $1,700 to a qualifying YouTube channel. It is one with 100,000 subscribers, something around there at minimum, and science related in some way or another. Maybe not. Kind of, at my discretion, I will, yes, approve something outside of that category. But anyway, just to play a 17-minute video on the double slit experiment and critique it if they like, or provide me an opportunity to interrogate regular physics, the theories that I would argue they are selling rather than investigating and proving, that they're just selling like a religion. They're selling a story, and they want it to be true for some reason or other. They're devoted to it. It makes them comfortable, something, I don't know. And so they'll propagandize. They'll bend and cheat and do whatever they have to do. They will silence any critiques because they just don't want to have to deal with anybody arguing why, Jonah couldn't fit through the throat of a whale. Yeah, they just don't want to deal with any of the facts. And, they just want to prop up a notion of reality that's just, demonstrably unproven. That's the first statement. It's just that it's unproven. It's unestablished as some sort of you must believe fact. It's way short of that. And, but that's not what they're selling. They're selling the truth. So, yeah, I have sort of become my tagline, I can only reason with you. And there's tons of evidence that physics really is cheating, that it really isn't seeking the truth, that it really isn't fairly investigating, that it's established an idea and it's just trying to collect images and ways of saying things that support that idea. And if there's if there's reason to doubt, they'll keep it, under the rug. They'll keep it behind the furniture. They'll keep it out of the room, because again, it's they need you to believe, because for some reason they're fully invested and they want to sell the stock. Frankly, that's what it sort of adds up to. Is they can't admit their fallibility because then they can't demand respect and money. They're invested in the theory personally, and they're just trying to sell the stock to everybody else so they get richer. Something like that, anyway. It's just not. It's so dishonest. I'm just saying that you really can't say that these people are honest scientists trying to find the truth, because it can't be made to smell that way. Because they can know better, and they haven't even tried to know better. You can see the evidence that they just don't want any other theory in the way, because of the corners they're cutting. And, they're not hard to find. Alright, so I'll play some of this 1960s stuff, which is really good because you get to see stuff. But it's really bad in that, yes, it's just, in a sense, propaganda. And it's just been regurgitated and remanufactured. Most of these MIT videos I found, the older ones, are all just duplicates of what Professor Lewin did, in the 1990s and 2000s when he was a teacher. He just stole all this old propaganda and was just selling the old propaganda, essentially, the engineered experiments. Every single one of them, just about, I've found, that he plagiarized it, essentially, in my opinion. I mean, there was some sense that some of this performance art of Professor Lewin's was actually, these were his original arguments, his performance, his demonstration of the experiment, and it's just a regurgitation. Even the little falling monkey and the gravity, there's a 60s version of it. I mean, it's just, frankly, you have to know those videos to know what I'm talking about, but I mean, they're just all duplicates of this stuff, okay, when this quantum mechanics was being sold, hard, and it's really just, it's so flawed. So this is where they're using the radar experiment now to say here's another example of how Young's theory is correct, this two-wave theory, and it's just so obviously flawed, as an analysis. So we'll play it.
We're going to do a microwave experiment now, which will be directly analogous to the Young's optical interference experiment you saw just a little while ago.
So it's going to be so undirectly analysis, it's incredible in the sense that, they're going to take two radar horns. Now the problem is they're just creating two sources, and that's really the single slit experiment. See, the single slit has two surfaces, and the fact is all their mathematics and everything they do is really recognizing two sources. And that's just the fact. And the sources are the surfaces. That's the distance they use in their math. It can't be denied that it's the two-source experiment. So if you have just two sources, all right, it's not the double slit experiment, it's the single slit experiment. So right there is it's, again, this is just obvious. You can figure this out by just thinking a little bit about it, that, okay, you're not duplicating the double slit because really you only have two sources here. And that would be the single slit, or the single impediment.
Only in this case, the waves will have a frequency of 9,000 million cycles per second.
So again, they always say the waves, the waves. It's never been, they haven't established that as a fact, and so many of these experiments demonstrate that waves just don't work. And, later on, Richard Feynman's going to say it's not a wave, but people are just going to keep saying it. Wave. No, it's not a wave.
Corresponding to a wavelength of about 3.3 centimeters.
Period. Okay. A distance between, lots of other ways they could say this, a frequency, but they always have to turn it into a wave. You must believe in the wave because you must believe in our ether. You must believe in our fields of stuff that isn't real. It's just a field in an imaginary space of 4 dimensions.
We'll produce the microwaves in a tube called a klystron. Here's one. The microwaves come out from this antenna. We pump electric charge or current up and down this antenna, and the accelerated charge sends out the wave.
So that's, as I understand, is a form of with a diode and some other kind of crap. So that's basically just it amplifies a frequency. You put a frequency in, it can give you more frequency out, because we really can't make a gigahertzy kind of frequencies are difficult, especially back then. So they need this tube to do that for them.
We've got the same klystron in this metal can. The accelerated charges on the antenna start an electromagnetic wave down this pipe.
So again, more wave. So it's basically light is going down the pipe, right? It's photons. Okay, it's not a wave of stuff. It's not blah, blah, blah. It's photons. Photons are going to travel through this apparatus.
The wave reaches this point and splits and arrives at these 2 points with identical phase. We then feed them through these 2 horns out into space.
Out into, yes. And so it's just 2 sources with the same frequency. So it's duplicating the single slit in the sense that the idea is that something's happening, 2 waves are happening somehow, and obviously it's at the surfaces because that's what the math dictates, the math that works. So you have 2 sources producing the same frequency. So they're just turning on and off at the same rate. Right? It's that simple. And we, again, just know you're just using the slits in the other experiment basically for the purpose of creating the two sources, for creating 2 points at which these 2 signals are going to be, you're taking one signal and converting it to 2 by having surfaces.
The purpose of the horns is to minimize reflections, which are caused when we make the transition between the pipe and the space.
I don't know if it's minimizing reflections. I think it's to steer, okay? It's to try to keep the energy from escaping in directions that aren't going to be in the experiment. So the horn directs, okay, the energy in a direction, helps force it to go one way, and especially on the receiving end.
The 2 horns in this experiment will act just like the double slit did in the optics experiment.
Right, so again, the theory that there's 2 waves in the double slit experiment, just understand that math completely fails. 2 waves doesn't explain the pattern in terms of its complexity, nor does it even get any of the pattern correct, except in 2 circumstances, where you have the slits insanely small, or you have the center impediment insanely small, essentially eliminating them as influences in the experiment because you've created such a... See, if I put 2 horns here, you can expect there to be vectors of difference, path length differences. But if I put 2 sources here, there's no path length differences anymore. You've lost all the differences, so you've sort of negated them. So if you have a double slit experiment, you have 2 sources here, and then you have 2 sources out here. Obviously, the 2 sources in here aren't going to be doing much, in terms of affecting the experiment, because their distance is so small that they just become 1 source.
Here we have a detector, which is sensitive to the resultant electric field tangent to it. We're going to move the detector...
So more, there's all kinds of arguments can be made about polarization. They haven't proven anything about how that works either. But they'll tell us how it works, even though they don't really know how it works. They'll just tell us their chosen theory at this time, and it's now been established that you can't change any of those chosen theories. Once they choose something, once physics says plus minus, they've proven they can't change anything. So once they've established something as a truth, they're impervious to fixing what's obviously wrong. I mean, plus and minus is obviously wrong. Physics never decide, hey, this is kind of important, plus and minus. We should actually put it the right way around. And although it'll be terribly uncomfortable for a while for everybody to adjust to the new terminology, it's fundamental to the physics. But they wouldn't fix it. So I'm just saying, just imagine how all this other stuff that, isn't, it's not, it's a little side stuff over here, a little side stuff over here. They don't fix any errors ever. So as soon as they start telling you it's doing this, or this is happening, or some other thing is happening, they won't ever change it, even though the evidence demonstrates it's wrong. They'll just keep doing it that way.
Forth through space this way, thus sampling the total electric field resulting from both these horns.
So again, this electric field rhetoric, they don't know anything about this field. They don't know one exists. It's just talk, blah, 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 field, blah, blah, blah.
Point in space. The output of the detector will be fed to this meter. Now let's do the experiment.
Okay, so the good news is he says, okay, they're feeding the output to that meter, and I think that meter is actually measuring the radar, the microwaves. And this is 10 gigahertz, pretty good signal. I think it's 10 gigahertz. Yeah, 10 gigahertz. Yeah. So, but he said nothing about the sound wave they put on top of it. So you'll hear that part.
As I move the detector this way, across the incoming waves, you can see that the deflection on the meter goes through a series of maxima and minima.
Right. So he has a tone on there, but this needle is apparently measuring the actual frequency, the actual carrier frequency.
You can also hear it on a loudspeaker we've hooked up because we're chopping the microwaves 1,000 times a second.
Right. So I'll do that on the board eventually, but I mean, all that means is the frequency. The radar signal is being sent in chunks at much lower frequency. There's a very high frequency, very high, and they just stop it and then do it again and then do it again, and that signal ends up being the sound you're hearing.
Just as in the optics experiment, when a crest from one horn meets a crest from the other, we get a constructive interference or...
So all he's saying there, it's not anything to do with crests. It just has to do with vectors, lines, that you could just draw on a piece of paper. And the point is that when the lines are a certain length, when two things are meeting at a certain location because of the angle at which you're moving, when those two lines are a wavelength, in phase, that is, the distance is a full wavelength difference, not a half a wavelength difference, then you can reconstruct the radar. The radar would be complementary to each other. But if it's a half wavelength, then what's really happening is you're taking a frequency, it's a certain frequency, and you're overlapping the pieces of the frequency. And when you overlap them, you can't receive either one. So they knew, this guy knows, that if he wanted to just jam the signal, he would do exactly the same thing. If he wanted to show what signal jamming looked like, how you jam a radio receiver, he would do exactly the same experiment. So he knows jamming is an alternative explanation for any kind of wave interference. He also can figure out that he can't do this with laser beams or with light beams. He can't send two light beams out and have them do this interfering with each other. It won't happen. Okay, so without the slits, it doesn't happen. He can't make the light bang into the light in the middle of the field, all right, and cause interference. He can't do it with any other kind of radiation. He can't make any other kind of radiation bang into itself without creating some experiment where he's doing something, some impediment, some obstacle, something to in some way disrupt the photons, to interfere with their progress. So it's really showing that interference, okay, is the fact that you put something in the way of the light. That's what you're really demonstrating, is that you're causing interference by poking something in the environment. Now, there's nothing in the environment. There's no slits in this experiment. There's nothing. Again, it would be analogous. He knows he can't do this with visible photons. This experiment won't work with visible photons. Well, partly because he can't create two light sources. Well, he can, really. He can split it and send the two light sources from the same frequency, the same distance, and keep them in phase. It can't be done. All right, he can't demonstrate that this whatever photons are, that you can bang them into each other and cause them to interfere with each other. And certainly this idea that it's the single photon is clearly not evident in this experiment. So you have to believe both are possible. It's possible not only to bang photons that are different photons into each other, but that somehow when I do it this other way, a single photon splits in two and then interferes with itself. So they're arguing for both kinds of interference. They're saying they can make different photons interfere with each other. Clearly these are different photons coming out of one of the horns and a different photons coming out of the other horn. And they're saying it's doing the same thing as the photon you created by having one photon split into two wave functions and have the wave functions interfere with each other. So the logic is horrible. And again, it's right overtly in your face. The simple answer is you're jamming the signal. It's clearly the simple answer.
A maximum at the detector. And when a crest from one horn meets a trough from the other, we get destructive interference or a minimum on the meter.
So if you send two radio signals at the same frequency, okay, I can just put an antenna between them and I can just say in phase, out of phase, in phase, out of phase. And when they're out of phase, I can't receive either signal. The receiver can't figure it out because it can't see the carrier, because you've taken frequencies that are like this and you've done this to them. Okay, there's no, the receiver is seeing this, and you're saying, well, somehow the receiver should still see this. Now, it can't see this anymore. It can't see 10 gigahertz it's seeing 20 gigahertz. It's seeing, I don't know what that is, 15 gigahertz. It's seeing all kinds of gigahertz, but it's not seeing the one you're trying to tune. And so therefore it can't pull the signal out of the noise. You've created an overlap of the signal. It can't see it anymore. And that's just the simple answer, the simple fact. Again, there's no way, even if, like I said, even if they conceded, that this wave interference thing didn't happen, he could still do this exact experiment and show that it happened, even though he doesn't believe it happens, because it's still going to happen because of signal jamming. So it's just really bad. I mean, like I said, I'd have to believe he was pretty stupid, that he doesn't know that he's jamming the signal. That's exactly the same math, exactly the same geometry. It has exactly the same theory. There's just absolutely nothing that doesn't make jamming the simple go-to answer. That's the answer. But he's trying to force it to duplicate the two-slit. It duplicates the single slit, the two-source experiment, so he can't get that part right. I mean, it's so bad. It's just propaganda.
In order to show that this is really an interference phenomenon, we have to show that both horns are simultaneously involved in producing the resultant field at the detector.
Yeah. So obviously this is going to show not that both horns are at all necessary. All you need is the one horn. But anyway, it doesn't. Play along.
Remember, we stopped at a minimum. Let's close one of the horns and see what happens.
So now we're going to take away. So you have two signals overlapped badly. So now we're going to take away one of them. And oh, obviously I have this left behind. Yeah, it's a nice clean signal.
The intensity on the meter went up.
Now, if you listen to the sound, you'll really be able to tell what's going on here, because the sound is going to get, well, let's just do the next experiment and you'll see it. So the needle is past half, okay, which is sort of interesting. If you would have covered the other one, it would be interesting to see if there was more. So he's not on the central maxima. He's actually at he's at one of the other maximas. So you can sort of detect right from that he's not at the central maxima, because he's getting more signal from one. So it only went a little past 10 on the meter when he was getting the biggest signal. So he's obviously off on a maxima, but it's not the central maxima, because now he's getting more energy from one horn than he is the other. So he just covered the weaker horn, so he's over. See, this is what you can deduce just by paying attention. You can deduce all of these facts. So he's obviously that way. He's towards, well, he's towards that he's towards that horn. He's over closer to the uncovered horn. So he's moved the thing over that way, and he's not on the central maxima. He's one over at least, because you're getting that higher mark on the needle. And if you, like I said, if you just switch the cover to the other one, it would probably be a little bit below half.
Means that the field from this horn can no longer cancel the field from the other.
So he says the word cancel, it's an okay word, but I mean, he knows that's exactly what jamming is trying to do.
Let's go back to a maximum.
Sorry, he was at the minima. Obviously, you can't be in the center and be at the minima. You have to be over. So, my mistake for saying that word. Maxima instead of minima. Obviously, one of the minimas is already has a bias on one side or the other. And the bias was showing right there on the meter. But you can sort of see it right here from the camera angle that he's not in between the two horns. So this maxima isn't the central maxima, one assumes. I mean, it could just be a camera defect. I mean, the angle of the camera could be off.
And now again,
Alright, so this part, just listen, and you can hear part of this thing, telling you the truth. Watch the needle, watch the needle. Okay, so the needle goes to half. Okay, and
in this case, the intensity on the meter went down.
Yeah, a full half on the needle, but the sound went way down, right? A lot more than half down. I mean, a lot more. So that's just showing you that this is another example of, come on, they could tell the truth. They could go the step further and say, oh, when we chop that wave, what we're doing, that's like called modulation. We're modulating a wave. And when we go to when we go to define the carrier signal and try to amplify the signal that's on it, we end up doing this arbitrary thing where we make the amplitude of the signal being carried, that is the chop signal, we amplify it 4 times. That's what happens in the process of actually receiving a signal.
This is because we closed one of the horns, thus leaving only the intensity due to the other one.
So let's just do that again so you can hear that huge difference.
And I'll again close one of the horns.
I mean, way down and only half a movement on the needle. So the needle's telling you that half the signal's still there, but clearly the sound isn't just half as loud. So another giveaway to the gimmick.
In this case, the intensity on the meter went down. This was because we closed one of the horns, thus leaving only the intensity due to the other one. It's easy to show that microwaves can be polarized. If we place a screen like this between the horn and the detector, you can see that in this position the intensity on the meter is relatively unaffected. But if I rotate the screen by 90 degrees, the intensity on the meter drops almost.
Right, and this seems opposite to the antenna polarization argument. Because, it's easy to go through the bars that way, okay, than trying to get something that's shaped to get through, bars going this way. But the truth is, this thing isn't a photon doesn't have solid polarization. It's not a solid object. It's an object that has pieces inside of that polarization. The polarization is completely permeable. So there is no difference between going this way through or going the other way through, beyond the fact that if you're going through crossbars this way, any change to your bits is all in the same direction that your polarization is in. So if you're going to reconstruct or fix that kind of photon, it's easier to do, because they're going to be in the same direction as the polarization. But anyway, that's a whole nother argument. So I'll let them finish this segment and then we'll move on. But these are really 2 different subjects, polarization and wave interference.
To 0. The reason for this is that in the second position...
So he's going to tell us the reason, but they really don't know any of this. They don't have any reason to be certain or sure or confident, but they're going to tell us that this is what you got to believe, because this is what we've said is the truth. And again, they'll never change what they've said is the truth. They can't go back and fix anything.
The electric field was parallel to the wires. This set up strong currents in the wires.
So then we should be able to detect all of that, So he won't show us the experiment where he detects a whole bunch of energy in the wires. So these are where all the flaws are. They're just going to tell us. They're not going to show us. They're not going to prove it. They're not going to demonstrate it. They're just going to give us this is what we constructed as a potential theory. But we never tested it against a whole bunch of other theories. We never sat down in some, conference somewhere or did something where we all put all these ideas on the table and picked at them and, had some kind of fair vote about what theory makes more sense. None of that ever happened.
Converted much of the microwaves to heat. In the first case...
So much of the microwaves to heat, but we know that really didn't happen because if he puts another filter in, he can get some of the microwaves back. So they weren't converted. They were just damaged, and then you fix them. You mess them up, and then you fix them. You unmess them. And that's the simple explanation. They're not destroyed. They're just a little bit out of alignment, and you put them back in alignment.
The electric field was perpendicular to the wires. Not much current flowed, and most of the microwaves got through.
So again, he won't show that by showing how the wires pick up a little more energy in this position than they pick up in this position. Because he won't be able to demonstrate that, because you could sort of just say, obviously, it's not going to matter. the energy is going to be the same, and all it means is that, because of the alignment of your radar is already polarized in one direction, one of them is going to be harder on the light. It's going to mess it up more, but it's not going to absorb anymore.
You have noticed that in this experiment, the microwaves were already polarized as they left the...
So that's what I just said. So that's where it makes it a little more interesting, is when you already have polarized light.
horns. The important thing is that we could polarize them, just as we were able to do with light in the optics experiment.
The important thing is you say things that you haven't proven, which is somehow if I put the screen this way, I absorb more energy than if I put the screen this way, which you haven't demonstrated.
And once they were polarized, they retained this property as they traveled through space. We showed you this when we placed the screen at some distance in front of the horn. This meant that the microwaves had to carry their polarization property with them as they traveled to the screen. Incidentally, it's easy...
Of course. If you break the polarization, it's like breaking the frequency. You're breaking something that identifies it as a photon. So, it's that simple. So, yes, if you disrupt those things, disorganize them. So, but disorganizing is very different than capturing or reusing or something like that. You haven't used the energy. You've just put it in a form that can't be received.
It's easy to measure the wavelength of microwaves. If we place a reflecting screen behind the detector, we can pick up a standing wave pattern. And by measuring the distance...
So again, more standing wave pattern, which would be the same exact... You'd have exactly the same statement if you were arguing for particles. Bullets would do the same exact thing. If they're coming at a frequency and you want to mimic their frequency, you just change the distance and it changes what order the bullets are in and when they're going to arrive. And so it's exactly the same argument. So this doesn't demonstrate wave behavior. It demonstrates the behavior of anything moving at a frequency. I could do it with bowling balls. I could do it with birds. I could do it with frogs. I could do it with anything that is frequency dependent.
Distance between minima, we can get the wavelength of microwaves. Let's go do it. I'll put up a reflecting plate in back of the antenna. The wave coming out of the horn comes down this way and bounces off this plate. At the position of the antenna, we have...
It should probably be a parabola, right? It probably should be.
Both an incoming wave and a reflected wave. As you know, the sum of two such waves gives the standing wave.
So it's a convoluted thing. You can see it's not shiny, okay? It's not flat, because the whole point is to sort of create a parabola out of a bunch of little angles. So he's going to have a bunch of different reflections going back to the receiver, the receiving antenna.
I'm going to move the antenna in this direction and follow its position with this pointer. In order to allow me to measure the standing waves, I'll put this centimeter stick behind it as a scale. As I move the antenna, we go through a minimum, max.
So understand, it's the same exact principle for anything at a frequency. You're just bouncing it off the wall, okay? You're letting it pass the antenna, the sum of it, and it'll bounce off the wall and come back, and that distance is going to be the same as any other distance in the sense that all you're trying to do is get the frequency to do this instead of this. If it does this, no signal. If it does this, signal. That's all.
Maximum. And let me stop at a minimum and mark the scale.
So obviously the distance is twice. You're going this way and then you're going back this way. So you're really going to how much you have to move is going to be half of what the actual wavelength will be.
Now I'll move the antenna to the next minimum. And mark the scale again.
So you got 1.5 centimeters, and basically come out to 3 centimeters, and blah blah blah. So, not, yeah. So, yeah.
The difference between these two marks is just 1.65 centimeters. As you know, standing wave minima occur every half wavelength. This means that the wavelength of these microwaves is twice 1.65 or 3.3 centimeters. The most common
Okay, well, the real truth is it had to go both ways.
use of microwaves, radar, is probably familiar to most of you. In radar, we shine microwaves onto an object and measure the time it takes for the microwaves to go to it and come back. If we take half this time interval and multiply it by the speed with which microwaves travel, we can calculate the distance of the object. This speed turns out to be exactly equal to the speed of light.
Yeah, so that's all well established, blah, blah, blah. There's no contention there, but that's not what these experiments are demonstrating. They certainly didn't demonstrate that. But anyway, we don't need to see that.
Our last experiment is in the radio wave part of the spectrum.
Right, so it's going to be identical. Same experiment, really. It's just that you have to do it, on a much bigger field because you're using a much bigger frequency. But that'll be the only difference. So it's the same thing, so we probably don't need to, we'll show it.
Here we will work at a frequency of 140 million cycles per second, corresponding to a wavelength of about 2.1 meters. Because of this large wavelength, we obviously have to work with much larger physical apparatus and in a larger area.
So they go outside. Well, anyway, I've shown this before in videos. It's not new to some of you. But it's the same experiment. And again, the same exact argument can be made that it's just showing you signal jamming. Two sources will jam each other if you make their path length differences, if they're out of phase. Then that's all you need to do is have a competing signal out of phase, and you're going to break. Most radio receivers aren't going to be able to deal with that. And the only way they can deal with it is to be directional, to sit there and just focus on one antenna or focus on the other antenna. So if they can exclude the signal from the other antenna, they can receive the energy just fine. So the energy is hitting all the locations. And it's just in that place, I can go to one of the dead spots, and all I have to do is put a directional antenna, and I'm fine. Okay, there is no interference. I'll be able to receive the signal just fine. So clearly it didn't interfere in the space, because then it would be already broken. So it clearly isn't being broken, it isn't being interfered with, and it's frankly just proves the point that it has nothing to do with wave interference. So if he simply had a directional antenna, and again, he knows what these things are, no doubt, and what's the big deal? You just cone your antenna, shield it from the other source, and boom, I got my signal back. And then I just pointed at the other antenna, I got that signal back. So there can't have been any interference in the space, in the field. The field didn't interfere with the field. There was none of that. All you did was jam the signal. All the energy hit that location. So just as the radar experiment that he just did, where you're getting no signal doesn't mean there's no radar hitting there. The radar's hitting just as much there as it is hitting everywhere else. All right, it's just that you've jammed the signal there. But if you did the same thing and put the radar cone on and you just did a directional antenna, you'd see that all the signal is there. So both cones are producing the signal. The signal's reaching that location. It's just that you've made it impossible to receive with a certain kind of receiver. Won't be able to receive it. And that's it. But if you measured heat, you'd see that the radar's hitting there. Same amount of radar that's hitting the other locations if you just measured how much heat was being generated. Or you use some other way to measure the absolute amount of energy hitting the location, you'd see that there's just as much energy hitting. It's just not hitting in the right form to be recognized as a photon. And then you could just extrapolate this to the light experiment and figure out the same thing is happening. The places that are dark aren't really dark. Okay, they're not really not getting hit by photons. They're just not getting hit by photons that are in the right order, that have the pieces in the right order. All the pieces are hitting, but the pieces can't be seen as a photon because they're in the wrong arrangement. And it's the same answer. You're just jamming the photons in a sense. You're breaking their frequencies. And by breaking their frequencies in their phase, okay, you've made them unresolvable as green or red or, a color of light. And now they've just become noise. they've become the same energy that's creating gravity and magnetism and other things. They've just become another form of heat instead of a specific kind of radiation in the sense of a specific frequency. Alright, so a couple of the other little facts I'll throw in. I mean, the video I've done on the two slit experiment, basically what is a photon, the sensible answer, goes over a lot of this stuff. But another obvious fact that just totally, he didn't do any math in this particular, in this particular description, but clearly he's showing you a flat screen that he's running his antenna on, right, for the radar experiment. And he knows mathematically, okay, that this experiment is kind of dependent on you recognizing that this distance is going to be in the math. This will be a critical distance, how far away you are from the sources. And then the other critical distance is the distance between the two sources. So you have two really important variables. I mean, I guess we could call this L, because that's usually what they do. Length. I mean, it's not really as descriptive as it should be. And so they know, right? These are smart people. They know math. They know all this kind of stuff. This distance doesn't change. So when they do their analysis of what happens here, well, they know they can't have the same L, right? I mean, this line to here has got to be longer. So unless they change the L in the math, they're not going to get the answer for here, okay? So they know when they do their math, the L has to be the same length. It has to be the same length line. So, the simple truth is they know this experiment has to be understood on this arc. I mean, it's not a circle just because you have a little extra here in the middle. But they know that, right? They're smart people. They have to know that. So they have to know that this was always wrong. That the math isn't predicting what the pattern will be on that straight line. Now, in the case of when you're going meters away, this arc becomes less and less important. It becomes almost flat, and so there's almost no difference. But just to understand, it's really important when you start talking about what's happening here. Because you won't see this, okay, on the flat screen. But you might see it here. Okay, so photons that you would have seen, you're not going to see because you're trying to project them too thin. They'll be spread over too big a distance. I mean, it's the inverse square law, by the way. Okay, so as you go further and further away, you're getting less and less density of photons. So you won't see a pattern that might be here because you're not recognizing that this is where the math says it is. This is where there's an on. Here. Not here. Here. Okay? Because that's the right distance for you to do your path lengths from. This is the distance you're supposed to be using to do your path length difference between this one and this one. So the math is predicting here. Here's where it predicts. Here's where it predicts. Here's where it predicts. It doesn't predict, see? Especially when you go further and further out, right? You can kind of understand. It's not predicting this. It's not predicting this. It's predicting this. Okay? It's predicting this location in space. It's not predicting that location in space. So, I mean, these are simple arguments. But once you understand this thing, that the whole pattern is on this arc, I mean, it becomes quite obvious that, oh, well, I should never imply that this was an infinite pattern, because clearly it's a finite pattern. And clearly, here's my maximum path length difference right here. Right here, I have my maximums. And if I just put little marks on this longer line, okay, that are the same length as this distance, I just put little marks on there. And now I just tie these two pieces together and I just move them. Every time there's a notch, that'll tell me where a node is. And what I'll find here in the middle will be very interesting. Because here in the middle I'm going to have notches on one side of the line, and I'm going to have notches on the other side of the line, exactly half. And I'm going to end up with, probably, I'm going to end up with some sort of weird number like, 8.2. Now, that can't be a maxima because it's not a whole number of wavelengths. So I'm going to end up with this weird circumstance where right here in the middle, it's supposed to be, oh, this is obviously equal distance. No, it's only equal distance inside of this 1 millimeter. Inside of this 1 millimeter, it's equal distant. okay? This little tiny shred of space right here, that's where it's equidistant. But in reality, these two, this line and this line, when they go the same way, when I go with the straight line from this and the arced line from this, it won't be a full wavelength. It'll be some less than that. So there's really two nodes here. There's a node here and a node here, and a dead space in between the two. That's the highest likelihood. And, well, then we can figure out that the signal, you know, that just goes, if it was a slit experiment, you understand the slit is just going to fill this part in. So, you know, the signal going straight through from both sources is just going to fill that in, so you won't see that. But, I mean, that's going to be the real pattern mathematically. And again, just understand this two-source experiment is duplicating a single source, a single slit in regular light photons. So, you know, even for him to say this duplicates the Young double slit when it's only two sources. And again, the fact that they keep saying the Young double slit when Young's analysis was wrong the day he drew it. When Young drew two waves coming out of the double slit, it was wrong. It was plain wrong. Okay, you have a double slit, and he draws it as, well, there's two waves, and the two waves interfere. This, okay, won't work because the point source is here, and the point source is here, and there's only two of them. Okay, and you can't make two patterns. That is, you can't have the complex pattern of the slit experiment. The slit experiment is going to produce two patterns. Okay, a pattern of on and off and a pattern of on and off. Right? I mean, the little bits are going to be on and off, and then there's going to be another pattern where there's dead spots here and here, indicating that this is a node, this is a node, and this is a node, and so it's two patterns. And you can't make two patterns out of just two waves. But you also won't get the right distances. See, this distance is not going to give you the answer, which is going to be made out of this distance. The right answer is going to be made out of this distance and this distance. And this distance isn't that. So you can't get the right answer from drawing your vectors from the center of the openings. The center of the openings will give you the wrong answer. It'll say they're in phase when they're not in phase. It'll give you the wrong answer. So it's been wrong for 200 years, and not one single physicist points that out. That Young's analysis is completely flawed. The double slit has to be understood as the four-surface experiment, the four-source experiment, if you don't want to deal with the word surface. But this is where the waves have to be, right here. This is the center. You have four waves from these little centers. Now, I mean, logically you can understand, well, that's kind of strange. The waves come in this way, and I'm getting tiny, tiny little wavelet here. So somehow a big wave comes out here. Now, I guess I could draw that. I mean, it's like saying that, you know, if I was to enlarge this, my chalk's running out. Chalk's running out. Anyway, that, you know, you have one wave here, and then you have these two little waves right here, right on the edge. Okay, and these are the ones that are creating all the fringe. So every bit of fringe pattern there is, it's all coming from here. All right, none of the fringe light, so the bars, none of the stuff out here, none of it's coming from here or here or here, anywhere in here. It's all coming from right here and right here. All of it comes from those two sources. So all the fringe patterns, so if you just take away the surface, you know, if there was some way you could just catch all the photons that were coming off this little edge, have a little bucket here, and just prevent them from going anywhere, you know, without creating new surfaces, you know. Unfortunately, you just can't do the experiments that you need to do, because they're physically impossible to do without messing up the, you know, recreating the surfaces. But the idea would be, if I could stop that surface from sending photons, there would be no pattern at all, you know, just a lump of light. And obviously that doesn't happen. So just huge flaws in their analysis. Clearly, it's just propaganda. It's just, we've taken the evidence and we're going to skew it and bend it. And we're going to take all the facts and we're going to just present the ones that indicate that this theory that there's waves and fields and complexity and mush, They're just going to keep saying that's the reality when you don't need any of that stuff. And there are simple explanations, and they'll never show you why those simple ones are wrong. You'll never see a video where they show jamming doesn't work as an explanation, because it does. You know, it's simply the simple answer. And again, you could demonstrate it so easily by just using directional antennas. You can just prove there can't be any interference in space. Because if you use a directional antenna, you'll just be able to see that nothing got interfered with. There was no interference. The photons are getting to the place that says there's no photons. Well, that place has plenty of energy getting to it. And all I have to do is have a directional antenna, and I'll see that there's plenty of energy getting there. So anyway, it's just all I can do. Like I said, I can just reason with you people. I've tried to explain that. I showed you the little pieces of these clips of history. You know, and the whole 1/2 mv squared, how its origins is horrible. You know, it was basically just, you know, reinventing a religion based on a tiny experimental fluctuation, you know, a tiny aberrant experiment, an experiment that made things look a little different. And they focused on that difference and just pretended all the other experimental evidence didn't demonstrate something completely different. I mean, these are the mistakes. And they're huge. And I could go back to Einstein and this lousy Eddington experiment, a horrible proof. And I could point out again, you know, the resolution in space is 400 times better. You can see 400 times further. You can see 400 times clearer. It's 400 times the definition. Okay, so you've heard of high definition. 400 times better in terms of resolving power from space. And they never duplicated the experiment from space, when you can do it every single day of the week. You don't have to wait for an eclipse. It's a simple little photographic experiment. You take a little tiny time-lapse photo. It takes 10 minutes to do. All right, and you know, 50 years we've been in space and they haven't even tried it. You could do it with a cheap camera. Okay, the optics are so much better in space, you could just do it with a cheap camera. You don't even need a telescope. And they haven't even attempted it with a telescope, with a good camera, with better technology. So in 120 years, we don't have one, in 100 years, we don't have one experimental effort that we've ever been in, you know, no one's told us anyway. Maybe NASA did try it and it didn't work and they just don't want to say so. But the fact is we have no evidence that in 100 years that anyone took some better technology to do the experiment and prove it. And they sit there and say the cornerstone of their science is repeat the experiment. You know, prove it. But no, they never proved that one. Anyway, I mean, all of this is so flawed. And there's absolutely no willingness by you people to concede this isn't what science should look like. Science shouldn't look like propaganda. Science shouldn't be underdone experiments. You know, experiments you never repeated. Science really shouldn't be about just telling us what the truth is. They should be able to show us that truth in an honest way. They shouldn't be hiding a fact like, well, of course the mathematics is exactly the same for a jamming theory. They shouldn't be not saying that, right? They shouldn't be saying, look, I got this experiment, it's going to prove it's a wave. But it's really not going to do that. I'm going to prove that it's interfered with in here, but I'm not going to show you that if I use a directional antenna, that theory can't possibly be correct. I mean, you think this is the way science should be? This is the way physics should be. It should just be, I'll just tell you the truth. All right? And you're supposed to believe it because I told you. I'm an authority. I'm wearing my little funny hat, whatever the whole thing is, right? I'm the Pope of physics, you know, like a Richard Feynman. You know, and I'm just going to decree what the Bible says. And then I'm going to decree what you should believe. But that's the irony. When the Pope says it, you don't pay any attention. When the Pope tells you it's not a wave, they don't pay any attention. Because the bishops have their own plan, and they're pushing their own wooey crap, and they're selling their own silly books, and their silly movies, and their silly crap. And you're just sitting there and eating this crap up, and it's crap. You scrape at it just, like I said, you don't have to scrape at these assertions very hard. You don't have to sit there and pick at these experiments very hard to find flaws in the logic. Just like you don't have to pick at their derivatives very hard. When they're deriving these formulas and saying this equals that, you can find the flaws, like in the 1/2 mv squared argument, where they go through a derivative where they're basically saying velocity equals acceleration, and so now I can use an a instead of a v when they're fundamentally different. I mean, acceleration takes time. Acceleration can't convert energy perfectly, where velocity is a established substance, its amount. Velocity has a steady amount, and they've turned it into something that is progressive and changes over time. I mean, all kinds of little crap like that just demonstrate how flawed all of this crap is. And I have to sit there and plead with you. I have to plead with you to recognize that this is a snake oil. This is a medicine show. Physics is a medicine show. All right, this isn't. They really are just trying to trick you. They probably would stoop that low if it was to their benefit. To put a little earphone in their ear and do all kinds of chicanery to trick you. Have some fake person come up and say, "How I'm cured by the bottle of crap." I mean, that's the shenanigans are that bad, and it's right in your face. We did it, even though our theory is insane and can't possibly be right. We measured we measured the half, 1/1000th of the fatitude of a proton, or some other bullshit, and it can't be true. Come on. But I have to plead with you. Please, have some integrity. Please, save yourself, really. Save yourself. Save your integrity as a thinking human on planet Earth. All this evolution, all this crap to get here where we actually have brains and we're supposed to be able to use them. And here you are just showing that, no, you just can't get past being a religious dupe. Monkey see, monkey say, monkey do. You can't do anything but mimic. Follow along. You're just proving you might as well just go bah, bah. You're just sheep. Led into the pit of stupidity, of stagnated, retarded fantasies. Believe in the fantasy. Don't try to understand the reality. Alright, that's probably enough. So I surrender. Well, I'm not really going to surrender. I surrender for this day. But I will endeavor to persevere, no doubt. And hopefully by endeavoring to persevere, I actually will persevere, but we'll see. And such, and so forth and whatnot. Oh, yeah, I'm supposed to do this first. This has been a DraftScience video presentation. Such.